In 3.2h, I'm going to show you how to construct and interpret residual plots to assess if a linear model is appropriate. Let's define residual again. It is going to be the difference between the observed value of that response variable and the value of the predicted by the least squares regression line. If we can compute a residual for one piece of data in our scatter plot, we can do it for all pieces of data, and that's what a residual plot is going to be. It is when the plot with the explanatory variable on the horizontal axis, and the residual this time is on the vertical axis. So it's like a scatter plot where the x value is the horizontal, but this time the residual is the vertical versus the y values going there. Residual plots are used to determine whether a linear model is a good model for describing the relationship between an explanatory and response variable. What you're looking for is a good plot shows no obvious pattern, and the residuals are small in size. So you're just looking for some scatter all over the place, but not a lot of scatter. We want it to be small in terms of the plot. So for example, if these are our x variables and we take every scatter plot dot and compute its residual and we plot it, if for example it looks something like this, where there's dots just kind of randomly scattered everywhere, this is a picture of all the error in the model. This would be actually considered a good linear model. Now if you plot the residuals and you start to see that there's actually a pattern to the dots, you notice here they're above the line, they're below, and then they're above. They create a pattern. This is actually a bad linear model. Another type of shape that's bad is if you were to see the residuals kind of start to create this funnel shape. So it starts out with a little bit of error, but then it grows into a bigger error. This also would be considered a bad linear model in terms of a graph of the residuals. So if we go back to our Honda CRVs, again, we have our equation right here in terms of the least squares regression line and its price hat, so the predictor. They're going to go ahead. We already did this on the previous lesson. We took a 70,000 mile car, which was at 14,450, and we computed its prediction. We computed the residual for that. And then what they're going to actually do is plot the residual. So this here is all of the residuals for all 11 cars. Here's the nice clean scatter plot, which remember under DOFST showed us a strong negative linear relationship. Well, we just don't want to look at the scatter plot alone. We want to actually plot the residuals. So what they did is they kept the x-axis the same, but they plotted the residuals. Is this least squares regression line appropriate? Again, the first thing we do is look at the scatter plot, which we've already done. After you've looked at the scatter plot and it kind of passes that linear test, then the second thing you're going to do is look at the residual plot. So if we look at this residual plot here, we're looking for some random scatter and not a real pattern. If you look at this, I would say yes, this is actually looks like a good model because there's just kind of not a real distinct pattern for this. So based on that, I would be able to accept this least squares regression line. You're going to notice this statement is listed a second time because that's how important it is. Remember, first you look at the scatter plot, then the second thing you're going to do is use the residual plot to justify your answer. If when you first look at the scatter plot that's not acceptable, you don't even move on to step number 2. It's only if the scatter plot seems reasonable that you would then go to here to justify if it's linear or not. Let's go back to the heights and weights of the students that we had here. One of the questions they want us to do is to find the residual for the student that's 76 inches tall, which is really the first piece of data. So remember on here, it's actual minus predicted or observed minus predicted. So we have our actual piece of data. The prediction amount, I took the old formula we found and actually found all the predictions. And then the residuals for everyone is just going to be the actual minus the predicted. In this case, this particular student has a negative residual, which means the model overpredicts on this one. So the model has a higher value than the actual. This residual sits below the least squares regression line. If you do that for all of the students, here's all of the observed, predicted, and residuals. I'm going to go ahead and take these x values on the x-axis and the residuals and sketch a residual plot by hand, and we'll make a decision if we think this should be a linear model. And we already graphed this x and y data, and it did look somewhat linear, so we're going to see if we can confirm this would be a good linear model. So if we look here, this is a residual plot, so we have the height on the x-axis and the residuals here. Remember, when examining the plots, we want to show no obvious patterns, and the residuals should be relatively small in size. So as you look at this model here, you want to decide if you think linear is appropriate. I would say based on here, there really is no defined pattern. Everything's kind of spread out. It's kind of a large residual, but in whole, it seems like fairly small residuals. So I would say here that yes, a linear model would be appropriate. Now I want to show you how can you make this residual plot on your calculator. So let's go back to the original data on height and weight over here from what we had, remembering that this is our x and that's our y. We want to go to our calculators and actually click on Stat Edit. So you're going to come over here and hit Stat Edit, and we're going to go to the lists. So we want to go into our lists, and remember, this would be list 1 and list 2. So type this in as list 1, this is list 2, so that they're in nice ordered pairs under Stat Edit. Once you have that done, you actually need to run your regression. So you have to go in. Now you're going to do Stat Calculate, and you're going to hit Stat Calc, the linear regression, like we've done before, and you need to run it. When you run the linear regression, you're going to get the equation. Now this data you see right here is for a different example, but the keystrokes work the same way. So once you've done your regression, the calculator has it stored. And when you run this information in your calculator, it's going to store the equation that we had on the previous slide. So what it does is it stores the residuals. The calculator actually computes the actual minus predicted and stores it under the word residual. So you can make a residual plot. Basically what you're going to do is try to create some residual plot like this. Again, this example down here is for different data. Here's the plot you're trying to create. So what you do is you make a scatter plot. Well, we've done that. How do you make a scatter plot again? You go to second y equals or second stat plot. You're going to hit enter into here. When you do, click on, select the scatter plot, which is the first one. You want to identify where your x's are, and for me, mine are in list 1. Now, because I ran this regression model down here, it has stored the residuals. Go into the y list here, and you have to go find the word residual. You actually don't want to type it, you have to find it. And where you're going to find it is under the Stat List button. So notice list is on the second. So hit second stat when you're sitting at this spot here. When you hit second stat, scroll all the way down. Yours might have more lists. Mine's right up front. That's the word residual. Hit enter and it will populate that in the Y's. Then go ahead and pick your marking and your color. When you're ready to graph, remember all we do is we hit zoom statistics, which is number 9. Zoom stats will then give you a residual plot. If you take this data that we have, again, do list 1, list 2, and then run your linear regression, your residuals will be stored. Then when you set up the actual scatter plot to plot the specific residuals here, you should get this residual plot, and then you can analyze if it's appropriate or not.